Hello. Am I too hard? You can hear me, obviously. Hi. I assume if you're in this room, you are familiar with ASP.NET Core. This is not a how-to ASP.NET Core. This talk is all about the hidden gems, in my opinion. Some of the things I found that is helpful, specifically for building ASP.NET Core APIs, for instance. To remind you, this is the hashtag for the social media. Please use it. And you can take pictures of my slides, share it on social media, and we're good to go. I am Fanie Reynders. I am originally from South Africa, living in Holland, working for a German company called T-Mobile. I'm a software architect by day, and by night, I'm a Microsoft MVP doing community stuff, meaning I'm part of the SDN event or the SDN network in Netherlands, and also have a local user group called the Dutch.NET group. And we also have a weekly webcast that you guys can follow along if you want to. It is in Dutch, but it's fun just to listen along. You also can find me on the internet at reynders.co. I blog there a lot, well, not really lots, but sometimes. All the code and stuff will be available on my GitHub page at Fanie Reynders. And also you can follow me on Twitter if you choose to do so. Please reach out, give me some feedback, and after the talk, maybe shoot some questions to me. Also done some content. Quite recently, I've launched a book, The Modern API Design with ASP.NET Core 2. It is available on Amazon. Go check it out. Just do note that if you're going to be searching for my name, you don't want the fanny packs. Or maybe you do, I don't know, but you just type my surname and you will find my book, and we'll good to go. So let's quickly start off. Like an application has a bootstrap mechanism, right? So if we're going to be talking about the startup process, the startup process of the ASP.NET Core application needs to be as fast as possible. So just see here, yeah. This is the simplest way of creating a ASP.NET Core application using the web host builder. Here we have a static void main function, and they allow you to have convenience methods to configure the services. That's the dependencies you want to wire up, and also have a required configure method that you pass in a delegate handler. That's your middleware pipeline. We all know this, but it is possible to define this in line, which is quite cool. But you can also, have it as a separate class, specifying it on the web host builder itself as type of T. In this case, it's type of startup. And then we have your startup class as a separate class with the method signatures like we know earlier. So let's quickly talk about middleware. You have application middleware, and then you have middleware that runs before the application middleware. We call that startup filters. Startup filters runs before the application middleware and also after application middleware. It's like middleware for middleware, kind of a effect. There's the signature. It's got one configure thing where you pass in a application builder sort of delegate, and the usage is quite simple. An idea will be, for instance, to check for a key. If the key is not 1, 2, 3, 4, stop the request. Reply back you had one job, for instance, and if it's 1, 2, 3, 4, let it through the application, because you need to handle the request as soon as possible before it actually gets into your system. And registering is as easy as just registering any other dependency in ASP.NET Core. For instance, you just go add transient, startup filter, and wire it up with the implementation of the class. So let's quickly go back to the separate class of a startup configuration. Did you know you can do it per environment? So let's say your environment name is development, for instance. You can have startup with a suffix of your environment name. Startup development, configure development services, and configure development, for instance. And this can happen on a class level, and also it can happen on a function level as well. So let me explain. So on class level, if we set our environment as foo, for instance, we can configure the web host to look for our current assembly. That's the first line there. To look for the startup class in the current assembly, and it will pick up, if your environment name is foo, it will first search for startup foo in your assembly. If it finds it, it will pick up that one and use its respective functions in there. If you want to be clever and say, I only want one startup class, but many implementations of its functions, you can totally go like configure foo services, configure foo, and as well, if you have bar, you can have configure bar services and configure bar and do something totally different in one startup class, which this can come in quite handy. When I saw this at first, I was like blown away. I was like, you know, it's like, yeah, imagine the possibilities, let's do it, you know? Because normally we do the if defs and stuff, don't do if defs, you know, just maybe do it this way. I think it's much better. So the reason why we're doing ASP.NET web applications is because we want to do applications that clients connect to servers and back and forth, right? So these two components, and it's very in REST, they are a very important concept, you know, the servers and clients. Did you know the server has an interface called IServer? Kestrel implements IServer underlyingly. So, and as you can see, the definition is quite simple. You have a features collection, which can be anything. It can be a request feature, response feature, cookie feature, body feature. There are plenty of features you can implement in your server. And also you've got a start and a stop. That is it. So Kestrel underlyingly implements this interface in order to serve the application as a server. Kestrel is the cross-platform HTTP server that ASP.NET Core uses out of the box. Just a request map, how it does. A server's responsibility, web server's responsibility, or a HTTP server's responsibility in a sense, is to read packets from the port, translates that into a HTTP context with the request, and hands it over to your application code. The application runs through its middleware pipeline, does its thing, and sends back a response. And that response gets handled by the server again, and then entailed gets be put back on the port for the request to be sent over the wire. I thought, well, let's implement our own awesome server. And then, but instead of reading it from the wire, let's read it from a file. So a file, the request is inside a file, and imagine you drop the file in a certain folder. The same thing happens, but instead of reading it from network, it just reads from a folder. The same request goes and response gets pushed back into a different folder. The same mechanism. This doesn't solve a specific business problem, but it's a very creative way to understand how we can actually create custom servers. So the syntax for the file, I've implemented this syntax, the HTTP method, space, and the request, and this is how we go be doing it now. So here I have a server running. On the left, I've got Visual Studio Code open, and I have on the right, I've got some you can't see my screen. Okay, that's a bit awkward. No custom desktops. Okay, well then we have to wing it. I have to open it again. Just a sec. I've got multiple desktops. This wasn't tested. First, I have to stop this guy. Okay. Let's open up this guy. It's still. What's happening? Let's kill this desktop. Sorry, kill this. Kill. Sorry, guys. Multiple desktops on Windows. Ah. Okay. What's happening? Okay. So I have to end my presentation though. What? It's wasting time. Okay, let's go see if this works. Yes, that works. Okay. Let's start over. You guys can see there, right? So So on the right, I have a process directory containing a few files. These files just hello, API hello. Other one is requesting a JSON, and the other one is just requesting an image. As you can see, it's listening. Okay, it's not listening anymore. Let me just start again. See, it's listening on a path, not a port. So the implementation is listening from a folder path. So, and it's listening from that inbox folder path. So take a look on the left, what's happening if I'm going to drop these 3 requests files into the folder there. It's going to be processing it and putting the output into the output folder. And the output will be hello world, for instance. We will have the object that comes back. And obviously there's the image that's Obama that gets read. Just to prove there aren't any smoke and mirrors in this case, we have a this is the endpoint it's called. So it's the normal application, but instead it just uses the, when you wire it up, you say .use awesome server, just like .use Kestrel. Instead you say use awesome server and configure it. Input path and output path. This is a custom thing I've wrote, but you can also write it yourself. Underlyingly, this extension method just wires up a singleton of IServer and pass in the configuration. Because of time, I'm not going to go into detail on this. We already lost a few time, but do check out the code on GitHub. It's under the GitHub repository Riga Dev Days 2018. I think my presentation has restarted now. Let's see where we were. Okay. Maybe I should just turn this off. Like this. Oh, this must be better. Okay, so let's shift our focus back to the client. So we talked about the server. Now let's talk about the client. HTTP client, it's the thing we all know and love. That's the thing we use to communicate to the server in .NET. It has a few downsides and a few problems. I don't know if you know, it implements iDisposable. Objective-wise, it disposes the object, which is fine, but underlyingly, the connection stays open. It's a Windows thing. It's about, I think, 240 seconds or something, the connection still stays open. It's not guaranteed that it gets closed. So there's no way of managing the connections at that level. If you're going to be instantiating an HTTP instance, a lot of them, you might end up going to socket exhaustion, which is not a good thing. So rather not go there. A solution to this problem might be to use a singleton, but that have other effects, like it will keep your connections open, which is bad for the DNS time to live, and it's very hard to test. They've actually yesterday launched ASP.NET Core 2.1 officially, which means HTTP Client Factory is shipped. Now, HTTP Client Factory is a factory that gives you an instance of HTTP client. And it works more on a delegating handler, kind of a middleware, client-side delegating handler concept. It's easy to test, and it comes with 4 types of usage patterns. Get my clicker. So the first one is the simplest one, the direct usage. You just add on your services, just go add HTTP client as it is. And then to use it, you just, in your controller, you just inject HTTP client factory. And then on the get method of your implementation, you will just go factory.createClient and then configure the client's headers, for instance, and then call the request out from there. This is the simplest way of using it, but do note it's the actual configuration happens now in the get method, not always very optimal. So the next method is the named client, where we actually move the configuration into an actual instance of itself. So instead of saying add HTTP client, we can now say add HTTP client and give it a name like awesome, and then move all the configuration with that name. The same things, just put in here as configuration, and the usage becomes more simpler. So you inject the client factory, and then you just call out create client because it has all these goodness already wired up for us. And the client factory will take care of the instantiation and all that kind of things for us. Then you have the type client, which is a wrapper around the HTTP client. You add it by going add HTTP client type of T, and this will actually then use the class, like in this case it's called awesome service. It needs to have a signature that has a constructor that gets a HTTP client in its dependencies, or in its constructor as a dependency. The same thing happens. You just use that instance to create your configuration, and then you have your strongly typed functions that you map to your function, to your actual calls out using the client. And then using it it's even simpler. Instead of injecting the factory, you now just inject the service instance, and then just use it as it is, .foo as a function and not a generic request thing. Malast is my favorite one, where you can actually, instead of injecting a instance, you can inject a factory. The factory I'm using now is is Refit. Refit is a runtime client generator thing. Very cool. Go check it out. Now, what Refit does, it uses the interface, and it, as you can see on the first in the first block, it maps the requests to actual function name in the interface. And then using it, you can go add HTTP client and pass in a factory saying, my configuration is a refit created a REST service for a type of awesome service. Then refit will give you a service that matches that signature and that request. And then using it, instead of the instance, you just pass in the interface. Much better. And then use it as expected. Who has ever heard of hosted services? Okay, so a hosted service, did you guys know you can run a background service in ASP.NET Core? I'm not talking about Windows services, I'm talking about actual, when your API starts up, you can have a separate process that does things at the back. This is quite handy if you want to do cleanup jobs or pull tweets, hashtag Riga Dev Days, and put it somewhere locally, like a cache or whatever. This is quite useful. So it's a separate process, or it's the same process, but it's in a separate thread that is running. So it's called hosted services, and the interface, it's iHosted service. It's similar to a server. It's got a start and a stop async functionality, where you just have to implement what you want to do when it starts and what you want to do when it ends. And using it as simple as wiring the dependencies, right? So you go add singleton. You can only have one hosted service, I believe, and you just wire your instance to the actual interface. Then using it, this is an example that uses Twitter when it runs. When it starts up, I call a function Spool Tweets, and when it stops, I just do nothing. And if you take a look at Spool Tweets, it just pulls in the latest tweets from a certain ID, hashtag Riga Dev Days, for instance, and summarizes it up into a CSV file and puts it on disk. Now, from there, that file can be accessed on our server. We can do stuff instead of actually going to Twitter all the time. We can just go to a local file, for instance. We talked about service, we talked about clients, we talked about other stuff. Now, let's quickly move into the concept of the REST components that ASP.NET Core is supporting. It is very focused on REST. So, meaning stuff like statelessness and all that kind of goodness. Validations, for instance, and this is where API controller can come in handy. API controller is also new in the 2.1 release. Normally when we do controllers, like validation stuff on our model state, we always go, for instance, if model state is valid, for instance. But we do it all the time. We need to do it all the time to validate the state. API controller, for instance, takes care of that. You can remove that code out of there. It acts as a filter. It understands the model that it's dealing with, and it can automatically validate the request for you before it even goes to that action. So it will respond with an appropriate validation error. It also has smarter bindings. Previously, you had to explicitly say from body when you're expecting a complex type in the request, for instance, but now it's inferred. So if you're doing a post and you're expecting a complex type, it's going to be most probably from the body. So you don't have to specify from body or from root or from query anymore. It's all inferred from the usage of the API thing. One thing to do note is that it does require attribute routing, so it doesn't happen. Normally you have to explicitly put in your attribute routes, but that we can cover later on in a demo with the conventions. It also has action result type of T. Now, previously, we have to respond with a HTTP response message that is action result, IActionResult, which is a HTTP response message. But sometimes we want to actually just return the value, like people or like int or whatever. But then again, you can either do one or the other. You cannot do both. So this makes it possible. It wraps the value. So if you wrap, for instance, if it's people, then you can just return people. But if it's bad request, you want to send back if something happens, that can also be a HTTP response method. It happens in combination. And then this is quite an example on how we can put everything together. You decorate your class with API controller. And then there's the example on how the action result type of T is using. This is a calculator that accepts numbers, two numbers, the second one being between 1 and 100. And all the model metadata for validation happens on the model itself. And then when that model is, let's say the number 2 is 200, for instance, it will automatically be handled by the API controller attribute and send back a validation response. And as you can see, it just returns, it doesn't think about a response type, it just returns the value. The response type is inferred as OK. You guys know what RFC 7807 means? It's a validation standard. ASP.NET Core also implements this standard. It's a way of giving validation in a readable format of the problem area. For instance, it looks like this. When the validation happens, it will send back an object looking like this, giving you number 1 is required, number 2 must be between 1 and 0, for instance, and also the type of thing. So it's the title, the status, and also the instance, for instance. You can add all these extra stuff to this validation objects, but this structure is part of that standard which is implemented. And how we do it is by just configuring the API options on our MVC stack. We just go .invalid model state response factory, and we create a validation problem details object where we put in our values that we want, and that is it. And then the attribute will use this configuration to give you the values that it needs. Model binding is a different subject as well. So model binding takes care of the things where we get thrown in a request with all these query strings and bodies and headers and all that kind of jazz, but we need to get it to a strongly typed object. And model binding takes care of that. So built in an MVC, it comes with model binders automatically. It knows when you're getting a JSON object that kind of looks like a person, it will try to bind it to your person class. That's what model binding does automatically. So, but you can also do your own model binders using the iModel binder interface. It has a bind model async function with a binding context, and it will let you loose to create your own model binder and just use it. For my example, I just thought, well, let's build an awesome model binder. Let's throw to the request a photo, like a photo with some faces on. And I want on my controller, I'm expecting an object that has emotional scores, like happy, sad, etc. Something needs to happen in between. I'm leaving that logic up for my model binder to solve. So my model binder will go to Azure, use the emotion API, and it will calculate the emotions and put it back into that object for me to actually work. So this is kind of the thing at how it will work. So let's quickly see if my demo works on this. So let's see, emotional binder. Let's open this guy up. Okay, it's still running, I think. So this is a photo. I didn't ask this guy's permission to show his face, but in any case, stuff happens. So this is a photo with all the emotions, and what we want to do, we want to send. Don't be afraid. This is just the base 64 of that same photo. We want to send that photo to my example endpoint, right? And we want to call it photo. And what we're expecting back is, if we look at our example controller, we're expecting it to be an object. So how do you go from the bytes of the photo to a strongly typed object that has the contents of the bytes and also the scores? Something needs to happen in between there, right? So let's first see how it works. So if I go, oh, by the way, this extension, extension I'm using inside Visual Studio Code to do the requests, it's awesome. It's called REST client. Go download it. It's very handy for these kind of things. So I'm posting to this endpoint, this whole thing, and hopefully this will work. Invalid URI. Okay, that happens. Okay. It will go, and then it will get back a response back from Azure. Now that's inside my my controller. So my controller just picks that up. My controller just picks that up and just returns the scores for us just to see how it works. Come on, go away. Dope. Okay. So the bind method, or the bind model rather, we read the photo property out of there from a value provider, and then we check if it's valid or not, and if it's eventually when it's valid, I call the get emotion result async functionality, which is the guy that actually goes to Azure to get the scores and stuff, and that will bring me back a emotion result object that has a face attributes object. This is specific to Azure now, that has a dictionary of emotions. And then going back, that's not supposed to happen. Going back to the, zooms out, sorry. Going back to the model binder, I create an object called emotional photo data transfer object, and I bind it to the success of the context as the success result of the context, and just return it. So that's the way how the model binding kind of works. Like I said, go check out the code further for more information on GitHub. So, this work? Cool. Who has ever heard of conventions before? No? One guy. So MVC uses conventions underlyingly to figure out what are controllers and what are models and what are all those kind of things. So by default, did you guys know you can, previously to make a controller, you call it foo controller and you have to inherit from controller or controller base, for instance. This MVC out of the box makes it possible for POCO classes to be controllers, as long as it has a suffix of controller. So you can leave out all the MVC stuff and just have a class called foo controller with some actions that turns into whatever. And if you have a function called post and get inside of there, it's already inferred as a get request and a post request. That is all conventions it uses. Now, it's also possible to build your own conventions. Let's say I don't like the names controller thing, so it uses the names controller as a suffix, and it infers the gets and the post and posts for the functions. But let's just say I don't like that way of working. Let's say I want to be able to make my own convention. You can do that by implementing the interfaces. You have a couple of interfaces you can implement. You have the application model conventions, which is the whole application conventions, but then you have conventions specifically for controllers and specifically for models and parameters, etc. But all of them share this about the same function called apply that accepts a model, like application model, controller model, and action model, for instance. This is basically how it looks from a bird's eye view. You have your application model, and it contains a API Explorer model with filter models and controller models. Controller models also contain API explorers, filters, and actions. Actions contains API explorers, filters, and parameters, etc. I do need to point out this is an abstract model. It's not the model itself. It's an abstract, which MVC understands. Underlyingly, if you implement something else, as long as it translates into this structure, your application will work in MVC, regardless of what the convention is. So I decided to make a convention of my own. I don't like the gets and the controllers and all that kind of things. So I want to be able to my root be inferred from my namespace, for instance. So look at my namespace; it's API.people. So why not have my my root of my API called API/people, right? And if I don't like the controllers thing, I like to call it an API. So names API is sufficient. So anything that ends on API is an API by trade. So this, it will now be a GET request that has a route of API people names, for instance. You can go a step further. Do you see the from services attribute? You can inline also inject your services in functions instead of having it injected in the constructor. This makes it handy if the service is only used in the scope of the function and not the class. But you can go further and infer that as well from the convention. For instance, if the parameter is interface, programmatically add the from services into my action model parameters, and it will be resolved during runtime. Then it'll be much more cleaner to work with the code. I've got a custom demo of a convention. Let's see. Okay. So there's my, yeah, you guys can see that there's my names API. It has a suffix of API, for instance, and it has a get that just gets the people. And let's just see if this works. So if I go to API people names now, for instance, I'll get my names back as expected on the right. So how does this work? Let's see. So we have this awesome convention. I keep on doing that. Let's try this again. We have this awesome convention. So what it does in the first section, it grabs all the controllers. Let me take a step back. This is an application model convention. So it's based on the whole application. So it gets an application model, and it scans my assembly for all the controllers ending on API. Then it will loop through those controllers, check a bunch of stuff, and build up controller models, and then infer the roots from the namespace, etc., 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 and then builds up the model as we're going. So it's a loop and a loop and a loop, and then eventually it gets that model, and then it will work. So in registering it, it's as easy as .add MVC, pass in options, conventions.add, and an awesome convention. Order also matters here, so you might need to, if you have certain conflicting conventions, you want some of the conventions to apply before the other conventions, you might need to use insert and have an index, just add it on a certain index level. That's it. That's basically the demo. It's going quick now, okay, so this brings me to the other thing they called application parts. Now, MVC, like I said before, they use conventions, but they also scan your assembly for all the controllers and all the building blocks that is MVC specific, and it sort of builds itself, right? But application parts might live on a different assembly, and if you reference that assembly, MVC will also know about that. It will pull in that automatically as well. But what happens if you want to, for instance, have a separate assembly on a box somewhere on a server, and it's not available during design time, but you want it to be available during runtime? Application parts can solve your problem with this. And this is as easy as reading a random awesome DLL from a random directory, for instance, get assembly, and then go add MVC.add application part and pass the assembly in. Now MVC will know about the assembly. It will load the stuff from that assembly and then build the application, which will run. Which got me thinking, how cool would it be to do a application parts that lives on Dropbox? Okay, it's possible, right? So let's see if it works. I hope it works. So I've got my Dropbox connection there. The link will also be in the code, which means you guys can also have access to this. This API is a normal controller API. It looks like this. It's got foo controller with a route external foo, for instance, and it returns hello from foo. And if I go into, this is not the one demo. So in here, there are no controllers. It's just the empty shell in this application. And what I'm doing is when I go to the program and I go configure services, I say add external MVC and I give it a URL. And the implementation of that is this extension method. So an implementation of that is I'm using a HTTP client. Then I load the bytes from the wire, and then I load it into application part. Boom, it works. Let's see if it works. So note /external/foo, and you get back hello from foo, and it's not even in the application. That's like run deploy time, pulling from the external sources, and it runs on the server without you touching it. So now you can maybe think about sort of microservice-ish kind of things, but that's not really microservices, but it's composite blocks you can make an application with. Right. $1 million question. What is HATEOAS? I see people go like, what? Well, HATEOAS means hypermedia as the engine of application state. Some of you are still like, what? No, really, it's a way of the client and server not knowing about state. And the client requests to the server from what it knows, and the server gives it back the next step, for instance. Let me show you. The client says, hey, server, what can you do? So it passes in, for instance, options, /. It needs to know about the / because it's its route. Then the server says, hey, okay, hi, client. Here's an HATEOAS response. This is the things I can do. I can have a few lists of foo and bar and bars, for instance, and you can do yourself if you really want to, you know. But note, it's by key. It's not by URL. So it gives you information. Then the client says, hey, I'm going to use the list bar functionality. And I'm going to pick out the URL you just gave me to request bars, right? Give me the list bars. Okay, client, here's the list. From this point forward, you can create a bar and you can call yourself. And there's the data. Then the client can go on and on and on. And let's say I want to be creating a bar. It uses the create bar key again. So create bar, pass in the post. And the server says, okay, you've created the bar. This is where it lives. You can remove this bar. You can update this bar. You can list this bar. And this is all based on the current scope of the user. So if the user only has access to delete things, you will get that functionality back. So delete one, for instance, that's actually using the remove bar thing. And then the server says back, okay, well, it's been deleted, but this is what you can do forward. So that's basically it. So it's a way of the client not knowing what to do next. The problem is what we do is we have a server that lives on a certain endpoint. We have a client, and when we update our endpoints, we always need to update our client. Your URLs we need to update and stuff like that. The web is intended to work on this principle. If you go to any website, you don't know all the links. You go to homepage, the response gets back with links. There's a new link. Well, I click on that link. Then you navigate further with more new links. And as you navigate, this is how you get responses back. HTTP APIs should work exactly the same. So I built a little NuGet package called ASP.NET Core HATEOAS to help out with this thing. Of course, you can implement this yourself in the controller. Instead of just returning the model, you can make a wrapper and put the links in there every time and response. But that will mean your controller will get bloated full of configuration stuff again, which you don't want. So I've created this little NuGet package called ASP.NET HATEOAS. It's version 1, yay. And what it does, it's basically giving a certain controller with a certain routes and certain route names like get people, update person, delete person, etc. This is normal things we know. Imagine we can have something like this. Imagine we have something .add HATEOAS, and we specify the options. I want a link I want a link if the return type is a person DTO, name it, and it's the name get person, and it's the the parameters. I want another link for a list. I want another link for an update, and another link for a delete when it's a person DTO. And underlyingly, it will generate that links for us. And this is how it works. So let me see. There we go. So the first one is a normal request without anything. So it will give us back a list of names with email addresses. That's my email if you want to email me, by the way. Don't send spam. And the next one, I'm sending application JSON plus HATEOAS. That's specific content type. Exact same endpoint, haven't modified the code. I just added this NuGet package with each configuration. And if I'm going to execute this, it will give us back a nice formatted response with links and items and links. Each item has a link and stuff. So the client can go take this rel, for instance, update person. It will then use the link it gets here, and it will go call put. And then Bob is your uncle. It will go further and further and further, and it's completely sort of stateless. You can get this on NuGet if you want to. This brings me to the end of my big presentation with my 12 gems. You guys can go figure out which is your best one. This is my favorites, for instance. And with that in mind, I would like to say thank you guys, and please rate my talk. Have a nice day. Thanks.